Hello, in the previous tutorial we saw how to use the context theory component to make the agent avoid the obstacle and other agent. Now in this tutorial I'm going to show you how to use the behavior area context theory and behavior. So let's add the behavior area after the direction behavior. Oops, not this one. So the behavior area starts to use the behavior area subsystem. So there are specific components that you can attach to different actors that force the agent to follow specific behaviors when the agent enter in their area. So it's a little bit different from the behavior component you attach to the group, because the logic is on a specific actor, specific component, instead to be on the agent group. In this way, it's more simple to prepare a complex environment where the agent need to do specific behavior when they are in a certain area. Okay, so let's start to create one empty actor. So we have a couple of behavior areas that you can use at the moment. There are those four behavior areas. Obviously you can extend in C++ if you want to create your own behavior, but also the behavior tree is the behavior tree area is able to execute a behavior tree, so it's quite flexible to generate specific behavior for the agent. But let's look. Let's start with the gate behavior area. So now I have the gate. Let's decrease the max distance. So what this behavior area does is basically when the agents enter in this area, it starts basically to target this gate and go through this gate. So this one, it will force all the agent direction that are in this area to follow the gate and go outside the gate. We can rotate the full actor or only the gate. It's up to you. Now let's have a look how the gate works. So we have a max distance that controls the maximum area influence of the gate. We have the size of the gate here. It says 100. You can increase the size, and also the maximum angle, that is this angle of influence. So we can have like a square gate with some influence here. You can even, I don't know, I'll put 150, so every agent that go in this area then start to go here and go through the gate. Let's leave 90. You can choose if you want the gate open or closed. So now let's play like this and see what it does. So you already see that now the agents are forcing to go through the gate. Actually, let me display the gate here. Then in game, let's remove this one. You will see what happens basically. It forces also the sample of the context steering to just one. In this way, the agent is forced to just evaluate this direction. It can't go in any other direction, and you will basically stop if there are obstacles, and you have this nice gate simulation like this. Here you can force the sample, use it inside the gate. Like you can choose, for example, only 2 sample if you want agent turn a bit. If you leave 0, you just do basically use the default value here. And here we can close the gate, and you can animate this value at runtime. Okay, now let's have a look to the follow curve behavior area. So let me add a spline here. Let me create some points. Something like that. Okay, so now we can attach a follow curve behavior area under the spline. And here we have all the parameter, the follow curve component that you usually use with the on the agent group. Now, oops, okay. Now if I press play, the agent should start, yeah, to follow the curve. Here you can use the max distance to lower the influence, for example. And see, then start to follow the navigation again. There is also a couple more options. One option is this keep agent on curve. Since the context steering can also generate force on the agents, this one basically will force the agent to actually stick on the path itself. Here, let's try with, for example, 200, and it basically you start to push the agents from the side to make the agent stick on the curve. This is useful for the queue that I'll show you in a bit. So this one is a follow curve. Then we have another one. Let me create an actor. And let's add a constraint behavior area. Let's increase this one. And let's set the velocity. Actually, let's keep the velocity like this. We can just animate this one, and so here function tick. Get actor location. Let's animate on the x-axis. Let's forward this one. Let's put 50. No, let's try. And then set actor location. Now should be, this one should generate a constraint between the agent and the actor. So as soon the agent basically inside is the area of the actor here, then it will inherit the transformation. Actually, let's look like hidden. Too slow. Let's force us to exaggerate. 200. save. Yes, he's pushing. Obviously, it's not right, but this way you can generate like elevator area or area like this where you need to basically move the agent basically on the movement of another actor. Let's remove the constraint. Let me add a behavior tree area. Okay, let me increase here size. And let me create a behavior tree. It's going to be a super simple behavior tree. Sequence, repeat, and set metadata. Obviously you can have your own logic here. Here for this example, just slow down the agent. So I am modifying the target linear velocity, so double, let's put 80. Let's save this one. Let's go back to our actor, and now let me connect the behavior tree. And now let's play, and now you see when the agents are inside the area, you just get the just run the behavior tree. In this way you can create custom logic per area. Here you have the global blackboard. This is the same properties of the behavior tree component usually used on the agent group. You can choose to stop the execution of tree when the agent exits, or continue to execute the tree. And here you can repeat the tree. If the tree basically stops its execution and the agent is still inside the area, you can still repeat. Basically it's the same thing. If I remove the repeat here, I save this one, and then I turn on the repeat. You can debug the tree here. You can get the actor there, and then you can choose which agents. This one is not the group ID, but it's the global ID, since multiple agents from multiple agent group can be in this area, so they can execute the behavior tree. Okay, now let's have a look to the last behavior area that you can use at the moment. Let's go back to our spline actor here. So we have the follow curve, and actually let me add the generic atoms behavior area. Let's move the spline under the area, and also let me add here as child a gate. Like this, let me create this one. Okay. So basically, what now is going to happen? Actually, sorry, let me move the gate a bit here at the start of the curve. Now let me remove the caps influence, so the curve start basically influence from here, and should be let's see, yeah, let's keep the agent on curve. So now what is going on? So these atoms behavior areas start to act like a controller for all its children. In this case, basically we are going to create like a queue behavior. So I have a gate, so the agent basically will try to reach this point, and then when they go out from the gate and start to follow the curve and basically form like a kind of a queue here. What I want to do basically is I want to override the stealing sample, because on the queue the agent must check only the forward direction. I don't want to check the side direction, so the agent doesn't try to go and pass an agent on the left or on the right. And then also basically this one is useful to control if an agent is inside this area. So instead to have like, I don't know, 4 or 5 different behavior area, you can compose everything inside this one, and during the simulation Atom just check one time per agent if it's inside this main behavior area. If it's inside this area, then start to check all its children. So let me press play. Let's have a look what's going on here. So now you see I'm forcing the sampling here to make the agent keep the curve here, and if I add another gate, for example, but this time I put the gate, actually let's put there, the gate here. Let's put here, let's decrease the one to 100. Actually 200 should be fine, and let's close this gate. Now press play. And now I have the proper queue. You can animate the gate, obviously, and this way you can generate some queue here. So this one is a way to compose multiple area inside a single area, and especially useful if you need to override the steering sample. So that's it for the behavior area. Thanks for watching, and see you in the next video.